This is Michelle Strain, and I am doing assignment number 3.1. And I'm going to run a one-way ANOVA test in SPSS. And what I'm looking at specifically is if there's a statistically significant difference in district enrollment between Region 1, Region 2, and Region 5. So that is the plan for right now. So I'm going to share my screen with you and we're going to work it out and see if we can do it. So now here we are in our data set. And the first thing we're going to do is we're going to go through and make sure only regions 1, 2, and 5 are selected. So we'll go up to data, select cases, if, and then I've gone ahead and typed in region equals 1 or region equals 2 or region equals 5. And since I already have that typed in, I'm going to click continue and then OK. And we have our data set. And so what we're looking here for is our regions and which ones are being used. So we know they're not being used if there's a slash mark through the number. So region 1, region 2, oh, look, not region 3, not region 4, but we will use region 5. So our data set, we did it and it ran great. So now that we've done that, let's see if our data is normal. What we're going to do that is go up to Analyze, and then to Descriptive Statistics, and then to Frequencies. We're going to click on that. And we're going to move our variable over. So we're going to move Enroll. And this down here, regions 1, 2, or 5. And once we do that, we're going to click on Charts, and we're going to look at we're going to click on histogram, show the normal curve on histogram, and then click continue and OK. So what we've got enough enrollment, so we know we have at least in 130. I mean, I'm sorry. We know we have 30 um, subjects, so variables. So we know that we need the first statistic that we need. Looking at that frequency table, we could have done that. And then now we're going to look at our histograms for this. So this one is a histogram for all three, and it kind of looks like a bell curve, but it does start pretty lopsided. So we're going to say maybe that isn't what we're looking for. So now we're going to look at the homogeneity of variance. We're going to go up to data, select cases, and we're going to use all cases at this point and click OK. And it's going to give us some information here. Here is our lopsided bell curve, which kind of is a bell curve, but not really. So I would say it is not normal. So now we're going to go back to our data set and click on Analyze, Compare Means, One Way ANOVA, and click this box. Now we're going to do the dependent list is going to be our enrollment, and the factor is going to be our region. And then we're going to go to post hoc. So you're going to check Tukey, continue, and OK. We're going to select Tukey, and then we're going to click continue. And we're going to click OK. Now we have some information that we have looked at. Now we're looking at some information here. So now that we see, if we're looking at between groups, we're looking at our significance as less than 0.001, which is less than 0.05, then there is a significant difference and we reject the null hypothesis. So it looks like we're going to reject the null hypothesis with this one right here. So now we're going to go up to Analyze, go to General Linear Model, then we're going to go to Univariate, click on that. The dependent variable is going to be our enrollment. Our fixed factor is going to be our regions. Next, we're going to click post hoc. We're going to look at region for our post hoc test. We're going to click Tukey, and we're going to click continue and OK. So let's look what it gave us. Now we're ready to run our one-way ANOVA test in SPSS. So we've already changed our columns on our regions, so we don't need to do that again. We've already run selected our specific data, so we know we're not getting regions 3 or 4, which shows that right here. So now what we're going to do after we've done that is go up to Analyze, Compare Means, One-Way ANOVA Test. So we've got enroll over here as the dependent, and the factor is region. We're going to click at this point, OK. Let's take a look. So our significance between groups is 0.055, which means that we have in Levine's test, we know that if it's greater than 0.05, we're going to assume variances. But it looks like if we look at the eta squared, our point estimate is 0.036. And so we know that if P is less than 0.001, then it is, but this partial ETA squared is the effect size. So we're looking now at effect size. So that number is right between small and medium, so we're going to call it a medium effect because it rounds up to 0.04. So on this assignment, I first filtered the data to only include regions 1, 2, and 5. Now, checking assumptions, the Shapiro-Wilk test showed a significance of less than 0.001. Since this is less than 0.05, the data is normal. The Levine's test for homogeneity shows the significance of 0.055, which is almost equal to what we're looking for. So equal variances are not assumed, and I will proceed with the ANOVA anyway. There is significant difference in enrollment between regions. In APA style, I report this as F parentheses DF1 comma DF2 parentheses equals F value. P equals P minus value, comma, N squared equals the value. Since P is less than 0.05, we reject the null hypothesis. The eta squared of the value is 0.036, indicates a medium effect size, meaning the difference is practically important.